Okay, this is your video for 11.2. Make sure you have your vocabulary and theorem chart filled out because there are a lot of new words and a lot of theorems, and I'm just going to assume you know them. So make sure you have that with you and filled out. Okay, so first we're going to start with arcs. You're already a little ahead on arcs because we skipped ahead and we did 11.3 during area. So you already found the length of an arc, and now we're just going to talk about what kind, major, minor, or semicircle. So find the measure of arc, KLF. So K to L back to F, that is 65% of the circle. So then that would be 65% of 360. So you can either set up a proportion if you wanted to. I'm just going to change that to a decimal and multiply it by 360. And I multiply it by 360 because there are 360 degrees in a circle. And I have 65% of them on this one arc. So that would be 234 degrees. And that would, of course, be a major arc. Find the measure of angle GJH. GJH, that works the same way. The measure of the arc, the measure of the angle should be the same. So 8% of 360. And that would be 28.8 degrees for that one. Find the measure of arc GH, or I don't know where I made that up, FG. So 20% of 360. And that would be 72 degrees right there. Okay, so these two are minor arcs, where this one is a major arc, depending on if it's less than or greater than 180. Okay, pause here and try the second one by yourself. Alright, so for this one I listed out the theorems that I used along the way because you actually had to do a little more solving on this one. So I got 128 for the measure of arc BD. I subtracted 180 from 52 to get what was remaining. And then DA, I added 97.4 and 52 to get 149.4. So this is theorem 11.2.2, which is on page 757, and you need to go over that and read that. But basically what it says, no matter which two you have, a central angle, a chord, or an arc, then if you have two that are congruent, then the following two will have to be congruent. So in this case, we have two chords that are congruent, which means the two arcs that they bound will also be congruent. So I can set 9n minus 11 equal to 7n plus 11. Because I know if the chords are congruent, then so must be the arcs. And then this just turns into regular algebra. 2n is equal to 22, so n is equal to 11. Be careful, they didn't ask me to find n, they asked me to find ws, so I got to go and plug that back in. 7 times 11 plus 11 would be 88 degrees. Okay, pause here and try the second one by yourself. Okay, this is going to be the same thing. They told us that two central angles are congruent, so I know that their chords will be congruent. So this is also theorem 11.2.2. So then I just set those chords congruent to each other. 14t minus 26 equals 5t plus 1. T is equal to 3, so when I go and plug that back in, it's equal to 16. Okay. Alright, these two right here, both of these, I'm covering this one up because I already did it for you. But these are going to be theorem 11.2.3. You can tell by the setup that it matches your setup theorem here. And this is the only kind of trickier one for today. Okay, so we know that this piece is 8 and this piece is 9, but they're asking me about this chord right here. So what you need to know about circles is because as we get to the end of the chapter, you're going to really have to do some thinking and some planning and some difficult questions. So this is one of the strategies to do with circles is if you don't feel like you have enough information, all I know is about these two pieces, how in the world am I going to figure out about this one, is to start with a radius. So I know that RM is a radius, and I know that it's 17 because it's 8 plus 9. So all I'm going to have to do is draw in another radius wherever I feel that that would benefit me. So if I draw in a radius, excuse my drawing, from R to P and label that 17, then it becomes kind of obvious what to do. I have a right triangle right here. I know this is 8, and I know this is 17, so I can do Pythagorean theorem. And 8 and 17 happen to be a triple, so I know this piece right here is 15. 8, 15, 17. But you have to be careful because they didn't ask for this side. They asked for n all the way to p, for the chord. So if this is 15, then this is 15. That's where theorem 11-2-4 comes in handy. That these are going to be congruent. So if this is 15 and this, no. That's silly. 11-2-3 is the one where we're going to call them congruent. So if this is 15 and this is 15, then NP has to be equal to 30. Okay, try the other one. This one, because the two segments are congruent, then when I change this, this turns into a 30, 60, 90 triangle. I know it's a 30, 60, 90 because this is x and this is 2x. So that kind of helps me out there. If you didn't realize that, then you could have done Pythagorean theorem and you would have gotten 10 on the square root of 3 by yourself. Since I recognize that, I didn't have to do Pythagorean theorem, so you want to look out for that. So if this is 10 on the square root of 3 and this is 10 on the square root of 3, then QR is 20 on the square root of 3. Okay, see you tomorrow.